it actually passed the test. So Awaitility is being useful to say we want to wait at most 10 seconds until this assertion worked, and the assertion was we received the print line message of message received test123. In this video, I want to show you this cool way of testing JMS listeners with test containers specifically by writing integration tests. So an integration test checks the functionality of a module with an external system like a database, web services. In our case, we need to test the Spring Boot app receive a message from an enqueue server. So first of all, what we need to do is, as you can see, there is empty Spring Boot test in here. All we need to do is just delete this file, and we're going to create our new file to test. Well, we can actually do it from the message listener itself. We can go to test, and this is going to create a new test, message listener test. Message listener is doing a lot of magic. Is receiving messages from a queue, from IBM enqueue. How we're going to test this file? Well, we can use Testcontainers, a tool that helps developers write better tests for their code. It creates a small temporary version of things that the code needs to work with, like databases, or in my case, MQ server. This means that developer can write their code more easily without having to worry about setting up complicated environments. So how are we going to do that? We go into our build or Gradle property, and in test implementation we're going to add the test implementation, and this is going to be coming from org.testcontainers, and Testcontainers, not the bomb, version 1.17.6, that's okay. And now we re-import to make sure the dependencies have been downloaded. So great. The first thing we're going to do is annotate this test as a Spring Boot test. So this means effectively we are loading the Spring Boot application or context, if you like. And now we're going to create a function that is going to initialize our container. So I'm going to call it setup MQ container, and this is going to return a type of generic container. And in here, what we can do actually, it's start our MQ container, generic container, and all we need to do is grab the details from here, the Docker Compose. So we need an image reference. It's going to be exactly the same. We basically need to make this piece of code into Kotlin code. So what we're going to do is that we're going to Docker image name, we're going to pass a Docker image name, and then we're going to say with exposed ports 1414, 1414, and with extra host, here we're going to put we're going to put a host name, localhost, and an IP address of 0.0.0.0. And then we may need some environment variable. So with the environment variable, let's have a look at the container. This is the boring part. So we need to say license accept and queue manager name QM1. I'm not even sure we need that, to be honest. Possibly that we can skip it. So let's just try with the license. So for that we need a map license that is going to map to accept, and that may be enough. So once we have this container, we have to hit mqcontainer.start. So we start our container before our test, and this function is going to return the MQ container. Cool. lot of codes for very little production code, isn't it? But bear with me, I think this is going to be interesting. As you can see, we have the connection name is going to be 0.0.0.01414. But what happens with Testcontainer is that typically is gonna spin up a random host and port number. So what we need to do is actually add this type of code, which is gonna grab the host after starting the container and grab the mapped port to 1414 after the container started, and then we override effectively this property that was showing here, ibm.enqueue connection name, with the format that enqueue accept, which is the host and then in brackets the port. And then after we've done that, we can return the container and we are ready to roll. So now, to speed up a few things, I'm gonna have to show you what I've been doing in my test, otherwise it's gonna be a very long video. So here we got our test. It says you should receive a message from enqueue. First of all, we say, given a message that we want to send, we're going to call it test123. Then when we put a message on the queue, we should receive it on the other end. So here there is a lot to unpack. First of all, why we need JMS template. We can use JMS template to put something on the queue, dev queue1, with this message. And then in here, we have to wait until we receive a message. And how do we do that? Because we don't have any kind of type of code in here. So what I thought is we can spy this object, the print line message received, blah, and then we can capture what happens with that and make sure that we receive that message in the format that we expect. The message we want is message received test123. We want our print line spy to match that. Printline spy is something that we're going to put above here. So first of all, we grab the standard output from system.out, and then we use a printline spy as a byte array output stream, put a before condition where the system set out is going to be our printline spy. And after all our test, what we're going to do, we're going to reset it. Okay, so we got one input, the message, and one output, the message received log. The other piece of this equation is the await. This is a great library called Awaitility, and what allows us to do is to do asynchronous type of test. To be able to use this library, all we need to do is to import the dependency, which is Awaitility specifically 4.2.0, and then we rerun the Gradle dependencies. And now in here, hopefully this is being received, and that's great. So let's have a look at the test once more. We got our setup container, put once in here, private val container, setup MQ container. So we are going to initialize our container. We are gonna spy our print line function, and before each test we are gonna set up the spy and reset it after each test. JMS template convert and send to put a message on dev q1, and on the other side here we are effectively testing that our message listener is wired correctly in Spring Boot. So let's give it a go. Let's run this test. So we have an initialize error, and I believe that it's because the life cycle. So if I add this test instance static, it's not gonna recreate it shouldn't be recreating our container over and over again. Let's have a look. Okay, so this has failed, but with a different message. So this is the MQCC failed error 2058. So 2058 says queue manager name error. Okay, so I was wrong. You remember when I said we don't need the MQ manager name? Well, perhaps actually we do. So let's go back here. I think we can fix this fairly easily. So I think everything is good so far, to be honest. All we need to do is, we need to add the MQ queue manager name variable, and we need to put this in the map of environment variables for the container. So essentially this, as you can see, is the same as passing these two environment variable. It's just needed for MQ server to run. So if we rerun the test now, hopefully all should be good. Great. So effectively, this is fantastic because it actually passed the test. So Awaitility is being useful to say we want to wait at most 10 seconds until this assertion work, and the assertion was we received the print line message of message received test123. So if you don't believe me, let's just put something else in there and we rerun the test. And there we go. As I said, this is gonna fail because it actually says we didn't receive X, we received test123 as a message. So I'm happy that the test is correctly working. Another thing that I'm gonna show you, it's if we run the test, and in the meantime I'm gonna go to docker ps, what we see here, Testcontainers is actually running, and as you can see, this is the random port I was talking about. Every time it runs, it's gonna instantiate a random port of 49160 in this case, and basically all this code is being just needed to test that this plumbing is working. So thanks again for watching, and if you have any question, leave your comments below in the video, and I'm gonna post all this on GitHub as always. Thanks, see you next time.